The old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds. We have Shawn Calderon here. Shawn, how you doing?
I'm doing pretty good. Glad to be on your show again.
Oh, dude, anytime you're welcome, brother.
All right, well, you ready for me to get started?
Yeah, let me pull it up. There we go.
Awesome. Hey,
all right,
guys.
Shawn, it's all you.
Thank you, sir. It's so good to be back with you guys. I missed you last week, and I was just catching up with Nathan, talking about what a good group of people that are in the chat. Smart, just awesome ideas. And so I just love to connect with you guys and share what's going on in my lab. So the first photo here you're seeing is I'm running my coil called the short stack. And what I'm doing, and I'm going to show you a little bit later, is that I was placing different stones to get them to interact with the top of my Tesla coil. And so what you're seeing here then is that little orange hotspot on the right. That's what is part of the rock that's heating up. And then it's directing all the plasma into one direction. And so I thought this was a pretty cool capture of that. And so let's get started. So, so it was my birthday last week, and I turned 55, if you're wondering. And my dad sang happy birthday to me in this video clip here. I know you can't hear the sound, but I think the video says enough. But I thought I'd share my dad. He's eccentric and he's fun. All right, so here's short stack. It's one of the coils that I introduced you guys in earlier presentations. And if you'll notice there, that's my hand on top. Now, we're talking tens of thousands of volts here, and yet see how I can touch it with my hand. One of the reasons I can do this is it's because it's a balanced system. And this used to frustrate me when I tried to extract power from this setup, from my setups, because when I look at this much plasma, I think, oh my goodness, this is propulsion. This is anti-gravity. Just there's something interesting going on here. But no, it's really hard to grab things from it because look at my hand. It's so balanced that it by the time it reaches my hand, it just has very little energy. And so as awesome as it looks, and I'm still working on this, I'm interested in transmutation. I do see possibilities in, propulsion, but for now, I just thought I'd share that I can put my hand on my Tesla coils. And I think I just hit the same video here. Let me check real quick. Yeah, sorry about that. Okay, so I'm getting into electrets, and so I've divided my lab into two areas of research. One of them is for electrets, and then one of them is for my plasma experiments and other types of experiments. And so this is one of the power supplies I'm going to be using, and it's going to provide an electric field between 5,000 volts and 60,000 volts. What this is used for is to electrify particles of powder or paint. And so I thought, well, if it can electrify powder and paint, then why can't it electrify materials to become electrets? Now, this is my guest room, my home. Forgive its messiness, but I'm building the electret fabrication lab in here. And so here we have the 1940s oscilloscope. I got R2D2 to take up the fumes. I bought this little panini grill because I'm going to be melting plastics. And I got a power supply. And if you guys recall from my last presentation, I made this sort of pizza oven looking thing where I zap electricity and I melt the plastic here, these little beads inside. So I put the beads in the oven, I turn on the power supply. That then provides power to this overwrite. It's hard to see here, right, of the red discs. And that puts out about 10,000 volts. And then it zaps the molten plastic, and with the hope of aligning the particles inside to keep an electric charge similar to a capacitor, but capacitors lose charge over time. And the idea here is that the electret does not lose its charge over time. So I'm very lucky where I live as it relates to working with electrostatics, which is electrets, because you need a very dry environment. And so I just want to give you an idea how dry it is here in the Chicago area where I live. And so inside, I have this sort of weather station outside my home and inside. And so it's 15% humidity in my house. And yeah, that's super dry. Plenty of lotion on the hands when you're working here. But this is great for electrostatics. And so I thought I'd share that because humidity is important. Now you guys have seen my little bingo ball holder here. This is going to be used for my adding rotation and movement to materials in order to cause a static charge. So there I got Teflon. I think this is a part of an old clip, but this is just to reiterate what I'm working on. And here we go. We got glass, powdered glass. So I'm just mixing all kinds of things together and trying to push out an electret. Now, I bought this bag of beads that they fill bean bags with or little dolls with. And these little balls, just pouring them out of this plastic cup, they had created so much electricity that it sounds like a bowl of Rice Krispies. There's just so much static electricity in the bag. I mean, you can't hear it, unfortunately, but you can imagine. And so I thought that was fascinating. I have so low humidity that I'm creating charge, high voltage charge everywhere. And so I thought that was interesting. And if you want to buy polyethylene for experiments, you can buy it. It's expensive for a little brick of it. It's like 30, 40, 50 bucks, which is outrageous. But if you buy these little beans for dolls, you can get 10 pounds of it for the price of one little brick. So if you guys are working on stuff, what should I say, electrostatic projects like me, then this is a really good investment because it's cheap and they give you a lot of materials and it's great. All right, so I am diverting part of my lab in the high voltage plasma area, and I'm going to get into bifilar coils, the hairpin coils, and this is one of the sketches, if you will, that I picked up in one of Tesla's works, and it's part of one of his patents. And so this is kind of my inspiration. I'd love to get a coil that size and be able to stand in the same room while all that power is leaving the sphere here that's sticking off the disc. So this is really intriguing and motivating for me. So it's on my bench, and so as you guys know, I go to thrift stores and I buy these LCR monitors, and I'm trying to see the price here, $5, $4.99. I'm telling you what, guys, go to the thrift stores and buy these up because these 20-year-old monitors, look at this. I got a piece that would cost you about 60 bucks on Amazon and maybe even more. This is acrylic or polycarbonate, but that is some amazing material. And so you're paying 1/10 of the price. And so here I'm showing you that I actually cut circles, discs, and yeah, it's not perfect. I'm not. I don't know how to do really clean builds like Nathan. I'm a little bit more rough around the edges, but this is allowing me to create the discs that I want and save. So now I've drilled a hole in this disc, and the washer here that you see, that sets the spacing. So I have what's called flat wire or rectangular wire, and it's 1 millimeter wide. So when I wind these, I want a 1 millimeter wide washer. And so this would not work also if the disc material was thinner, because it wouldn't keep its shape. It would bend and then the wire wouldn't come out right. But these hefty pieces of acrylic that come in these monitors, these LCD monitors from the 2000s, they work amazing. So I think I'm showing here a little bit more about it. There you go. So this is the flat wire. I was able to get 950 turns. It's 1 millimeter wide, but it's 0.18 millimeters thick. So this thin wire gives you so much, so many turns, and that's going to relate to voltage. So you're going to get a much higher voltage for the space, and yet the width of it is going to be able to handle currents. And so this was my first attempt. I had sprayed some release agent, and I touched super glue as I'm winding it, and it comes out like this. So this was a good first try, and here we go. So the steps are a little out of order, but you can see the flat wire over in the background. And so I'm getting ready to take that flat wire and wind it between the discs. Now, I hope you're not disappointed, because I don't do a whole lot after I made this coil, but I thought it would be cool to show you what I'm doing. So you can see there, this is called flat wire, but it's actually rectangular in shape, and it's fascinating. So if you buy magnet wire for your coils, let's say you paid $100 for a spool, this wire here is about double that. So it's not cheap. It's a specialty item. I have there's a factory in China. One of their sales reps, her name is Miss Echo. I developed kind of a email relationship with her because I'm picking up all the wire that I want, the specialty wire, and their prices are just so low. I can't buy wire anywhere else. So this flat wire came from that company, and I saved probably 60%. Pretty amazing. If you guys are interested at the end, let me know in the chat after my presentation, and I'll put the info. I'll put her company info, because she is a salesperson, and you guys can reach out to her and you can say, hey, I want wire 1 millimeter wide and 0.18 millimeters thick, or however you like your wire, and she'll give you some really good pricing. And then if you want just your general wire needs, they're worth it. They're usually about half price that you can get anywhere else in the US. All right, so I've got it all set up. And one of the things I do is I bolt it with a lot of washers on each side. That way there's no give. I mean, you can sneeze near this flat wire and all of a sudden it'll twist on you or something. So this makes sure that there's no room for that. And here we go. You can kind of see the winding process now. Pretty clean, pretty nice. Nice setup. And again, this is two LCD monitors from the thrift stores. That runs you $10. And you can do this with any wire. And you can even do this for winding bifilars. I can say it. Bifilar coils, which I'm going to show you in a little bit. I have an idea for that as well. So here's another angle of it. You can see my rough cut discs. It's terrible, but they do the job. So it was my birthday last week, and my dad bought me this. It says "Think outside the box," and so my dad wrote me a nice card saying that's me. I'm thinking outside the box, and so I said, Dad, I'm going to run some plasma through it. See if I can get about 50,000 volts coming out his head. And so here's my first attempt. I love how it's such a easy process now. Just hit a few buttons and it's all organized. Whew, it's taken me a long time to get this smooth. So let's see. Oh, check his head out. Yep, and his feet. This was cool. See how he's on my short stack coil, and it worked. He didn't add too much capacitance to throw everything out. So I sent this back to my dad, and he really enjoyed it. He said doing this was very outside the box. So thought I'd share this with you guys. A lot of personal touches probably today. Just want to share what's going on with my life and in my lab. I think I made too many videos of this. Let me see here. Oh, this is when I dialed it up. So I tripled the plasma. So yeah, he's really pushing out the plasma now. There's some real thinking there on top of that plasma. Okay, so I'm going to be experimenting with some spheres filled with certain gases. And one of the things I noticed is that the way the gases are interacting with the plasma from my short stack coil, uh, it starts to display behavior that is at the atomic level. So, we have in our minds, and we got this from our education, that an atom is like a little solar system, and you have the protons and neutrons in the center, and then you have these little electrons orbiting on the outside. But really, the electron doesn't really orbit. What the electron does is it appears more as in probability states. So instead of having a position, it has a superposition. And all that means is it's in a fuzzy area. And the only way we can find out exactly where they're at is to run certain scientific equipment. And then you'll find it. And then this fuzz disappears. But I wanted to just plant these images in your head, because even though this is an electron, which is something is absolutely unbelievably small, it exhibits patterns, three-dimensional patterns. And I want you guys to kind of think about these patterns. There's some more patterns that the electron appears in. Excuse me. Because these little glass spheres, they're going to start exhibiting some of these patterns, and yet, of course, they're dealing with trillions trillions of electrons. And so to see a single electron look like this, and then trillions of them together, let me go back here, which I'm going to show you here, look like this. It's pretty fascinating to me. It's almost like you have this macro vision of what's going on at the micro level. Another thing I wanted to share is this is the planet Neptune. And the reason why I show you this is because one of the primary parts of its atmosphere is helium. And so when I start running a little plasma through my helium sphere here, you'll notice that it looks just like the planet Neptune. And this was just amazing to me, because there's Neptune, and there's clips of Neptune where they don't add a little coloring. And when they don't add the coloring, Neptune looks exactly like what I'm holding here in my hand. And so this is another cool thing. Here I can hold this in my hand, and yet it looks like one of the ice giants, Neptune and Uranus. in our outer solar system. So, and the plasma here on the right's not touching it. It's just that the excitation aura is exciting the helium inside this sphere and giving us a mini Neptune. So here I'm going to do a little bit, forgive me, sipping the tea. I have a sore throat. So I have 2 points in which the plasma can come out. And even though this is glass, it prefers hitting the glass instead of the air. Now that is surprising to me because glass has more resistance than air. So if I place them to where they can, either of them can work, normally that it'll shift to the helium versus, the helium glass versus the air. And I wanted to show something here. Let's see if I can get back to it. I want you to take a look at when it strikes. So if you see the plasma striking where it appears in this white, these sort of white effects here. What's fascinating about this white part here is that it's creating fractals, and a certain kind of fractal you can see. I'm going to show better ones here in a minute, but I thought I'd find one. Another phenomenon here is that the glass sphere is actually pushing out plasma from its interaction. So that's really fascinating. I didn't expect that. This is one of those, another one of those here, this little point coming out here. That one's feeding again. So let's see. So I wanted you to also look for these patterns because these white, because they'll start to fractal or look like fractals. So here I do a drill in here, and it almost looks like Mandelbrot sets. And this is one of those streamers. So in the interaction, the sphere just there's like a pump. I know Nathan calls the Tesla coil pump, and it's so true because it's causing this suction and it's just pulling electrons right off the sphere. I call this the U-turn because it'll hit the glass and it seems like it just reflects back. So, excuse me, sometimes the violet turns white all the way from the output. I don't understand why it does this. This is a much higher intensity light, but it's something I'm gonna have to look into because this happens every once in a while, but it's not common. It's usually orange, a bright orange, or a violet and a purple. Here's another way. It looks a little fuzzy, but you can still kind of get a sense that we're getting fractals. And if it doesn't look like fractals to you, I'm going to show you where a fractal will match up to it. Now, this is a huge feeder, or it's a U-turn. I can't tell, but I thought this was really fascinating, this close-up. Pretty interesting. Again, it's just a glass ball filled with helium. Okay, so there's a bunch of cool guys that work with Eric Dollard and a lot of other big names, and they have what is called a golden ratio, Tesla coil. And these are the kinds of fractal images that it outputs. So if you recall some of the fractals that were occurring on the surface of the sphere, this kind of gives you evidence of, this is the large view of it, but that was a tiny view of the same phenomenon. Okay, so this is krypton gas. And if you guys recall the atoms, the electron, and it had those sort of waves of probability. This is one of the designs, or one of the probability fields. So it's pretty interesting how I shared earlier that you're seeing on a large scale what electrons do at the atomic scale. So I thought you would just kind of see that, and it's happening. It's pretty interesting. I barely turn on my Tesla coil, and this thing starts to ignite in this really pretty pale purple. Now, short stack has a issue of plasma coming out of two ends. As I'm handling this, okay, so now you can kind of see it a little bit better. Let me see here, because now you can look through the glass. Let's see. It's not doing it. Okay, I'll get us there. Sorry about that. So you'll see, I want to see if you can see through it. All right, so as you're looking through the glass, there we go. So you can kind of see these, it looks just similar to the golden ratio, and it's occurring there on the surface of the glass. And it's a lot brighter in person. I'm just using my iPhone, but I just thought that's so fascinating how you're getting those fractals, those white fractals that are similar to the output of that golden ratio Tesla coil that you guys saw earlier. And I'm holding this in my hand, not getting shocked or anything, and just enjoying myself. It's really fun to play with plasma. Okay, so here I sort of try to zoom in so you can see those fractal designs. All right, so you can see my test bench in the light, how messy. It's an old desk that I'm doing this on. And now this is argon, but I think they mixed it with either nitrogen or oxygen because the green is not really supposed to be there. I know Jared said he knew why the green was there. And I wish I could get a hold of him because it would be really cool to see that. So I just froze it at the perfect time as it's zapping my finger. That was not on purpose, though. I just wanted to show you something here real quick. Let's see. All right. Let's see. So now we're getting a little bit of a different effect. So if you can see here now, the white fractals are only the same color now. So argon seems to do something a little bit different. Let's see here. So it's interesting to me that they just lost that white fractal and it just turned purple. So that's an argon effect. Yep, keeps hitting me. I'm just taking it after a while. But I thought that would be interesting. Argon gas mixed with oxygen. And if you see this, again, it looks like these probability clouds. Now, these, of course, aren't perfect, but they come along similar than what I shared to you earlier. This is my messy guest room. I already shared this. Sorry about that. Okay, so this is a walkthrough of my office. I finally got it cleaned up. This is where I'm sitting now, and I got my vacuum chamber set up over there, and I have my computer that I'm sitting in front of right now. And I just thought I'd let you know the workspace I have. So I use my iPad there on the left. I have a 6-foot whiteboard, which comes in handy, and you can flip it. It has two sides. So yeah, it's a lot of writing space. It's just necessary for a person that has ideas all the time. And here's some schematics that help me decipher what I'm looking at, my messy shelves. And this is my soldering and build desk. I wind and solder on this one. And this desk actually goes up and down. So if I need to stand because I have a poor back, I can lift it up, or I can use the button to put it down. I can put it so low that I can sit Indian style on the ground and work. So this is my favorite desk. These things are outrageously expensive, but they sell them used. If you look them up, they sell them used furniture from corporate offices, And I'm telling you, these things cost the same as a cheap IKEA. That's how cheap they are. So it's worth the visit. Wow, change of context. Um, so I share some of the things I do with my core group of friends. So Joe, he caught this and showed it to me, and what he called these are null points. And when he showed me these null points that I'm using arrows to show, I can't look at plasma without noticing them now, and they're just fascinating. You have this plasma sort of working in a certain way, and there's really no rhyme to reason, though chaos theory would say it's ordered chaos. But there's these like dark holes where nothing is going on, and it's really close, sometimes in the middle of the plasma. So I should have made this bigger. So, and I don't know if these are interacting with other objects around it. I haven't spent a lot of time on it. I just thought that it was really cool that Joe found that. When I first demonstrated the plasma to Nathan, he showed that these are tendrils and they're twisting. And I thought that was amazing. But now, if you look here where my mouse is, I cannot not see these null points. And this null point's almost three-dimensional. It is three-dimensional. And so I see them everywhere. I thought I'd just share a couple examples. It was a good catch on Joe's part. What do they mean? I don't know, uh, but it's worth looking, or it's worth just noticing them for now. All right, so change in topic again. If you guys remember, I made an attempt to wire a pyramid and then cover it in epoxy. My epoxy job is abysmal. And then I tried to use it as a Tesla coil, and it was a big failure. And one of the main reasons was these grooves were just not deep enough. There just wasn't enough inductance to really push out any plasma. So here's another kind of picture of it. And I spent a lot of time on this guy, and he just didn't do anything. Good paperweight, though. So I went to the drawing board, and what you're seeing here is the grooves went from 1 centimeter to 2 centimeters deep. And then I have a friend of mine, he's an engineer and a CAD expert. He designed this little tip thing inside, and I just went crazy when I saw it. So you can see now that the grooves are very deep. But in the old model, the grooves would get shallower and shallower as they got to the point, which makes sense. But instead now, the grooves here, they're the same depth. Okay, so this is after I clean them up off the print job. These are also at a golden ratio. So we're looking at golden ratio. We're looking at 2 centimeters deep, at 1 millimeter wide. And these coils, they're not very big. They're maybe about 3 inches high, maybe 4. I have to do the conversion to centimeters. But they're going to pack a punch. One of the reasons why I want these deeper grooves, not only to hold more power, but I want to lower the resonant frequency. Nathan threw out the good idea that how would a low frequency Tesla coil operate? And so that's been something that I've been really trying to work out, and it's not easy. I've been able to get the ZBS to go down to about 15,000 hertz, but yeah, I want 100 hertz, or I know that's like undoable, but I want to try it. So these guys are going to help me do it, because they're going to have so much inductance that the resonant frequency is just going to go down, down, and down. And you guys know this. If capacitor values go up, resonant frequency goes down. If these coils here, the inductance goes up, then the resonant frequency goes down. So that's always the what happens with these phenomenon. So I have a 36-pound spool of 32 gauge wire. I'm sorry, 33 gauge wire. And I'm winding this pyramid, and each groove holds 5,000 turns of wire. I had to send my math to Ian because I was coming up with 8,000 turns of wire per groove, but he checked my math and said, no, it's 5,000 turns of wire per groove. Now, if you do the math, it's going to take hours to wind this little guy, but it's fun. Here I've spent days, and this is about the speed I do. I'm a little faster. I'm trying to get it with the camera, but I could probably do one turn about every 2 seconds, and I did the math. So it should take me about 90,000 seconds. So we'll see. But check that out. I think this is 35,000 turns of wire. And this is my therapy. This is my happy place. I mean, if I was offered a beach hut in tropical island or some other cruise across the sea or something, I'd pick this. winding coils. It's just, I love it. And so here I'm trying to show you now. The coils that wrap around are not just they go 2 centimeters deep, but they're also about 5 to 10 turns of wire thick. So that's where you're getting the thousands and thousands of wire. So I kind of give you close-ups of that. And so it's really pretty inside because you can see that this thing already weighs about 2 pounds. And yeah, I bought this super cheap in China from Miss Echo. Really good deal. Excuse me. So I'm almost to the halfway mark, and I'm hoping you can see. No, this is not the one. Here we go. I think this is the one. You can kind of see the design. I'm going to try to catch it here. Let's see. Is it going to come in? I'm just going to stop it. All right. So you'll see that there's a triangle in here. It goes like this. But when you reach here, it's just a skinny post, a skinny bar. And that keeps these depth almost all the way to the top. The depth stays deep. So this is going to be an amazing coil when it's done. All right, so I'm going to start zapping some rocks. I had some requests about, hey, it'd be interesting to see plasma interact with different materials. And so my kids, they bought this on a field trip. I think it was my daughter Lainey, and she gave me this with a bunch of rocks as a gift, and it was very sweet. The circles are around the rocks that I can make out. I think I need to wet the rocks to match this to this chart because I did more of these. And I didn't do all of these because I've lost a couple, I think. But I thought you guys would be interesting to see. I'm going to do agate, amazite, obsidian, green quartz, white quartz, and possibly other ones here that I just haven't figured out yet. And so the idea was to place a rock on this little copper opening on top. Excuse me. And let's see here. Trying to catch up here on what this is doing. I think what I'm doing is doing a quick op test to make sure that this thing's tuned in, ready to go, so I can start putting rocks on it. And so what I do is the tuning activities that I do, I work with the capacitors. I change out capacitors, and I just shave off a little bit of capacitance, or I'll add a little capacitance until finally this thing comes out super big like this. Also, too, you can listen to it. When you're really in resonance, it's quiet. It just has a gentle hush, and the whole room feels electrified. So those are the two indicators. If you're not in resonance, but you're getting good sparks, then you're hearing that really loud buzzing 60 hertz sound, and which is fine. This is not as loud as Tesla coils you buy on Amazon. No way near. You can get a little Tesla coil from China, and it's way louder than this. And by the way, it has none of their Tesla coils can produce what I'm producing here. This is a briquette from my barbecuer, and I thought, oh, what would carbon do? It's pretty interesting. It just sort of starts breaking through the brisket. Now, I had to be careful not to do this too long because it was actually, oh, white one blew out the back there. It started turning red hot. So, but I thought this was interesting. And this is the kind of things that from your comments, I think someone mentioned try carbon. So I know one of the requests was try to ground my rocks, but you just can't do that. So here's another stone. I think this is lava. Yeah, this is lava. If you remember the photo from the start of this, lava has the tendency to direct it. And the hotter that lava was getting, the more it was pushing out one side. I thought that was fascinating. It would not leave the other side. If you'll notice all the other rocks, they'll sort of climb around and sort of feel things out. Not lava. Lava keeps it all in one direction. And so that's how I got that really cool picture. But you can see how the lava gets really hot and becomes a source of where the plasmas come out. Look at that. So this is where I'm cranking it. I'm putting in close to max power. I'm sorry, the camera's all over the place, but it looks like a flamethrower. I have a ozone meter in my lab because the ozone sometimes smells really strong. And so if it gets into the slight, then I'm done. I don't want to get to the moderate. I start ventilating and I take a break or whatever. But this is a really handy meter if you're pushing out a lot of sparks because ozone's not deadly unless, of course, it moves out the oxygen out of your room. But it can cause like a burning in your lungs, and who knows what it's doing in your lungs. So little amounts I heard are healthy, but you don't want a whole lot. And so this was one of the cool photos that I got from the lava rock. So what is going on over here? That's pretty incredible. And there's just somehow it has a boost. I know it's adding more current, but when I add more current, it doesn't turn white and orange like this. It just doesn't. And the lava rock was not melting or anything. It wasn't. It was warm. I think I show the warmth here in a second. I'll have a infrared on it. I'll show later. It's another rock. I'm saying I think this is another lava rock. Yeah, it's a different lava rock. Kind of showing its same thing. It's sort of just pinching it, and pretty cool. I had a comment that said, "Take your time, don't rush." I get a little hyper, but you're seeing that red, hot. Oh, check it out! It actually pushed it off. But the lava rock's not too hot. All right, this is a mistake. Sorry about that. All right, I put this cover here that I printed on the 3D printer, and I thought I was just going to put the different rocks on top of it. The problem that I was having here is it was melting and smoking, so that was a bad idea. So no more of that. I'm going to put, you can see all the rocks that I have. And I'm sorry, I made a little a little mapping diagram. But so if you guys are interested in what these are happening, I'll do a little bit more organized. I just thought I would show you guys what they do with having tens and hundreds of thousands of volts of plasma applied to them. So this rock was just really evenly dividing it out. Thought it looked really cool, flattened things out. Also, too, the rock is sort of pushing down because you can see that it's coming out of the bottom of the copper piece that I put on to hold the rock. So you can kind of see that. Pretty interesting. Sort of acts like water under high pressure. Here's another rock. It's a green one. I should have had my mapping here. Again, just showing you guys how does it react under a few 100,000 volts. And I love the purple before it gets lighter and lighter. And it's pretty amazing photography for for a cell phone. This is looking kind of similar, not really doing anything different. I think the most exciting were the lava and the, oh my goodness, the carbon, the briquette. And so here, a white rock, I forget. Again, let's see how much energy I can pump through it. I'm just hoping, I guess this is maybe not the best way to do scientific investigation, but it's fun. And I'm so happy you guys are interested, at least in some of my experiments. It means a lot. I think this is the quartz, the white quartz or milky quartz. Again, just looks like a rock sitting on a big pile of plasma. Seems like the more I mess with plasma, the more intuitive it becomes. And it just sort of becomes, I don't know how to say it, but I can sort of arrange things and feel if it's not right or if it's right. And it's almost hard to explain to people too. So I'll get you guys through these because I wanted to talk a little bit about the Tesla coil and how it works with me. So we'll get through a couple more of these. Let's see here. Super pretty stuff. This is another white rock, see-through, probably another piece of quartz. I'm really zooming in. The camera's like an inch away, getting zapped. The camera's actually getting zapped by this, and you would never want your camera to get hit by static electricity, but this real balanced AC, I'll tell you what, it's all its energy is contained. It's very efficient, so it doesn't do a whole lot of damage. Doesn't do any damage hardly. Here we see again another rock. All right. Let's see. We'll get through these. I don't think there's any more differences. Let's see if this was, I think this one was interesting. No, it's similar to the others. There's one more that acted differently. I'll show you. Not this one. Oh yeah. So this was another little chip of carbon, and it went wild. I thought it was pretty cool. Good colors. I think that was the other rock. It's a briquette from my barbecuer. Pretty cool stuff. A little setup. Lots of plasma on this presentation. Okay, what is going on? Oh, so I went to a thrift store. I always go in their lamp section because in their lamp section, you can find the most interesting things. This is a 50, 60-year-old glass piece, and I think they were selling it for $5. And what I did was I ran some electricity at the bottom of it. You can see my Tesla coil is just pumping right into it. And it has different gases in it. It's very well made. It's got the thick glass, and it's not easy to divide the glass like this into different colors, because if you turn off the plasma, it's clear. So nothing's painted, nothing's colored. These colors are strictly from the gases that are ignited inside by the plasma. So I thought this was a little cool thing I found. Let's see here. So I'm doing it again. You can kind of see it in the light, what it looks like. I honestly didn't know what to do with it when I saw it. It was sitting on the shelf, and it looked like some gaudy glass glass rock that you put on your end table. All right, so if you guys recall from my last presentation, I was trying to make a ZVS coil that would never burn out, that would be indestructible. It would always work for you, and that it had that it was plug and play. Now, when I said plug and play, Nathan pointed out, "Hey, wait a minute, I see solder." And I thought, well, you got to solder a few things, but if your diodes go out, you can just slide the diode out, and or you can unscrew the MOSFETs out. You can pull these resistors out of the tubes, but these are soldered. These are soldered. So even though I was able to get the ultimate ZVS, the indestructible ZVS, to down to 10 components. And this is the circuit I'm using for all of the plasma displays that you saw earlier. I'm using this guy right here. And but it wasn't full plug and play. So Nathan pointed that out. So I'm going to come up with a plug and play solderless ZVS here in a minute. Now, when I'm always working with my Tesla coils, it always has a setup just like this. If you look to the right here, this is the Variac. You can pick this up on 15 amp. You can pick it up on Amazon. What the Variac does is it puts in an AC signal up through the diode. With the diodes, two diodes here, I have them in parallel, but it can be one diode. And what it does is it only allows positive part of the sine wave of AC to go down. And that positive part of the sine wave, what that does is it pulses this ZVS. Now, because you have two MOSFETs and it's already oscillating at, let's say, 100 kilohertz. Now, as this is working at 100 kilohertz, this pulse here that's coming in from the Variac is from your wall socket. It's 60 hertz. So what the wall socket here, 60 hertz, is doing is it's turning off the ZVS 60 times per second, or it turns it on 60 times per second. So that's why you get this sort of push out those lightning bolts. Then it flickers. That's the best way to say it. It sort of flickers. It's not a constant. And so that's what's going on with this Variac here. Now, this switch that says danger here, this comes from the DC that I put in here. And in the DC, that controls the oscillator. So the DC covers the oscillator, and then the AC comes in and powers the coil. Now, the simple parts you always need. You need a capacitor, which is this box of capacitors here, but you can use one capacitor. And then over here, you have this salad bowl looking thing of copper coil. That's the primary coil. And then this little guy here in the middle is the secondary coil. And so the bowl of pipe here and these capacitors, they set the resonant frequency. If you can get the capacitors and this copper piping, if you can get them to be at the same resonant frequency as the coil, the secondary coil, then that's when the plasma comes pouring out. That's basically what I'm doing. Now I use this little switch because I like to segment the power. I want to have a switch here. I want to have a switch here. I don't want it all to go to one thing. And the reason is it divides the problems, and it's actually a little bit more safer this way. And I hope this makes sense, and I can answer questions here in a little bit. Thank you guys for being patient. I know I'm going a little bit longer. I think I always say that. You can see that this is what the inside of my mind looks like. So just so you know, yeah, I don't know how to do a clean build. Not really, but it's functioning. All right, so I am building a new plug and play circuit. Instead of the Uber circuits that you saw earlier, I'm starting a new line called the Z series. And so this is Z1. And Z1, I'm happy to say that all of the components can be slipped out and replaced with no soldering. So thank you, Nathan, for that. This is the realization of it. Of course, this is just the first prototype. I'm going to have to do some tweaks. But yeah, this is it. It's going to be indestructible. When I say indestructible, I use these copper pipes because if you use circuit boards, you're going to burn up your ZVS all the time, and you're not going to be able to find out where it's burned out. That's one of the frustrating things about ZVS circuits. They'll just stop working, and you'll pull off every component, and they're all fine. But the circuit board just won't work. Well, I replaced the circuit board for all copper pipe, copper tubing. And now it's either the diodes or it's the MOSFETs. Maybe once in a while it's a resistor, but guess what? Everything can be pulled out. No more soldering. Excuse me. Let's see here. This is from last week. Sorry about that. This is that positive pulse that I was telling you about that goes in from the variac. It looks just like this. And these downward parts, that's when it's turning off the input power, and it's doing it 60 times per second. And that's why you get those big lightning bolts. All right, so I'm gonna try to build a bifilar coil. And I want the bifilar to have thousands and thousands of turns of wire. And so what I'm doing here is I'm going to set up 3 coils. And this coil on the right that I'm setting up on the record player here, and the coil on the left, I'm going to have them feed a 3rd coil. This is tricky here because I haven't mounted the record player to the plastic yet. So this is just for demonstration. And so you're going to have 2 coils of the same wire. And so if you look at the left, that's 1 coil. Look to the right, you have another coil. And it's going to feed here in this pancake at the bottom here, this pancake jig that I showed you guys earlier. And so the nice thing about this is I'm going to hook it up to my drill, and I'm going to pull in wire from the left spool and the right spool, and I can get a 5,000 turn bifilar. And I've never played around with bifilar coils, but I'm going to go big. And then if I get good at this, I'm going to then use the flat wire. The flat wire coming from 2 coils to feed it to 1, that's going to be a bigger challenge. And I want to walk before I run. So this is kind of what the setup would look like. So here I am. I'm going to spool. This would be, this is for, oh boy, if I wanted to fill up a spool first and then put it into the pancake from 1 spool instead of 2. So if I bring the wires down to this and fill up this spool with a bifilar, this would be easier than to feed into the pancake jig. So I'm just kind of putting things together. I hope these ideas or spur ideas, what you guys are doing. So this is, again, one of the setups. I'm just tying the wire to give you an idea. This is no way what it's going to look like. I think my voice is telling me that we're getting to a close here. Just another example of how I'm going to be winding these. Guys, I'm going to wind these, and then, oh my goodness, I'm going to try to get so much plasma out of them. And then I look forward to hearing your guys and what you guys think. And that's the end of my presentation. We went a little long, but that concludes it. Thank you guys for your time. Thank you for always listening. You guys are great. So Nathan, you still there?
Yeah, I'm here. That was awesome, Shawn. Hey, everybody give it up for Shawn.
I appreciate that. Thank you so much.
That was a great job, brother.
Appreciate it. It's long, so I hope I didn't bore you guys.
No, everybody was into it, man, the whole time.
Awesome.
I love the rocks and stuff, and then the briquette was awesome.
Wasn't the the briquette was quite interesting. I love I like Joe's observation about how there's these just super black 3-dimensional holes in the plasma. It's like, what is that? Right?
Yeah. Uh-huh.
and they're undeniable. At first I thought, what? There's no holes. And no, they're all over the place.
Yeah.
All right. So wow, lots of love in the chat. Thanks, guys. I really appreciate that so much. I appreciate it a lot. Hey, if you guys can show a little bit more love with liking and subscribing, and yeah, I mean, Nathan wants to get fun presentations out to fun people, or smart presentations out to smart people.
Absolutely.
So, all right. So I see people interested in the flat wire. Excuse me. Yeah, what I was hoping to do is have something that can handle current, but yet be in a small space. Oh boy, Nathan, I'm gonna have to let you talk for a bit. I need to sip on some tea. Sorry.
Yeah, not a problem. Give me 1 second, man. I just want to thank real quick. Thank you, Mr. Lanius, for becoming a member. I also want to thank Chris Hayes. He purchased 2 memberships to my channel for somebody out there.
That's
So
awesome.
I'll pull that up and show you guys who it was. But I just want to say thank you very much. It's always appreciated. So, yeah, I also just put some things on my channel. Tesla patent that was for Wardenclyffe. So I put that on there. All I did was AI voice it so that you could put it on in the background while you're working on something else and just listen to the patent of it. Also, I went ahead and put out another AI one in there. So sometimes it's a conversation with Tesla on this last one. Supposed to be his last interview before he passed. So it was a pretty interesting listen. So both of those went out on the members. So guys, for you that are out there as members, those are cool things that are going on. Also, Joe and I did an interview last night with 8th Center and also with Liz. And we talked about Atlantis again. So there's some members only stuff out there for the sneak peek. But we're going to be airing that later this week. So we're going to do a live on that one. That's going to be really awesome. We got a whole bunch of stuff coming up, man. I talked to John Bigman the other day, and hopefully we can work out a schedule for him to come on live. Absolutely amazing person, very intelligent, really, really cool. You know what I mean? There's some really good stuff there. So anyway, I just wanted to mention that as well. So, Shawn, you doing better now?
Yes, thank you for that. A little laryngitis, I guess, but I feel better, so I appreciate it. I set up my iPad here for the comments because for some reason they're hard to read with the bright light. They have a nice black background on my iPad. So, wow, guys, some really good stuff in here. Let's see if I can find some questions here. Dead Fish Cheese Spread talks about quartz and tourmaline has a piezoelectric effect. Tourmaline. If it's clear, it has a piezoelectric effect. That's fascinating. I always think of just quartz having the piezoelectric effect. Piezo. I can't say it.
I just call it piezo. I don't know any better either.
There you go, piezo. And I didn't know that. I'm wondering if all crystal-like rocks have piezo effects.
Oh, that's like a big question, man. I think they all do. It's like a combination lock. We just got to unlock the combination. Kind of like we were talking earlier. We're telling you about the Tesla coil and dividing down the rings. So just going through, finding all the radio frequencies, writing them down, building each coil to those frequencies, and then match them with the big coil that does all of them.
Oh, my goodness.
I think that the quartz works the same way. So that's my hypothesis right there. And I'm going to put it to the test. I'll build the coils, do it. You know what I mean? I'll put a bunch of quartz that's mashed up into a container with some water And when it gives you the electricity, it's going to give you a frequency. So I'll use that as the starting point and then build my coil to it. Man, I think we're in for something, a whole new revolution on this, Shawn.
I'm telling you what, objects have a resonant frequency, but they also have this, I'm going to make up my own word here, sub-resonant frequencies. And you can pick these up with certain tests you can do with an oscilloscope and a function generator, a signal generator. What you'll see is you can see first you have the what they call the natural resonance, and then if you think about maybe music would be better, you have these harmonics, these sort of complementary frequencies. And so for Nathan to find all of the resonant frequencies in a coil and then build other coils individually for each sub resonant frequency, that is amazing sounding. I'm going to say it. It is so crazy brilliant. Something that I've never thought about. I've always looked at these other resonant frequencies as, well, they're not as good as the primary, so why play around with them? But what you're doing is you're taking all of them, and in a sense, you're creating that coil again, but in multiple parts. And so how will that interact? It has to be in some harmonious way as the single coil, but it must have some individual properties as well. So to me, that sounds just full of opportunity.
Well, so let me throw this out there for you, and I got the idea this way. When you see geometry coils, a lot of times when people represent them, they represent them with frequencies on every single part where you find the air, okay, the oxygen molecule, and we'll say it's a hexagon, right? So you go 1, 2, you know what I mean, just like this all the way around till you get 6 of them. But they all represent as a different frequency. So to me, I thought, well, that represents the ring of the Tesla coil. So what I wanted to do was to match the ring to the frequency of the crystal. Therefore, if it does build out the way people represent it, then we'll be the first ones to light up a crystal with resonance. You know what I mean? All the way back in the biblical times of the Ark of the Covenant is the only last time that they've done it. So to me, it would be like a lifetime achievement to get that done.
The crystals have such high frequencies. To match that with a Tesla coil, that just sounds interesting. When you put an electricity into a crystal, then you get mechanical work. But if you get mechanical work to the coil, then it gives electricity. Sort of has this dual mechanical, electrical, what is the word? Transformation of energy. Because if you strike a crystal, that's the mechanical, and then you see the sparks. Now that spark, that tapping of the crystal has a frequency, and you're saying is tap that crystal, get its frequency, and then have a Tesla coil match it. So then,
well, not just that, we're gonna like a cascade or a step stool ladder, however you want to say it. We're not just going to hit the one frequency in there. We're going to hit all of them. That it's like a spiral staircase is the way I keep seeing in my head. You know what I mean? We're gonna tap every last one of them. I think one of the things that's underutilized in the crystal itself is you tap it once, it taps back, but it's natural frequency of one of them.
mm-hmm.
I think it's missing the rest. And that's the combination lock that we look for in resonance in order to unlock something. So sometimes it's one frequency, sometimes it's multiple frequencies. So it'll be the first time somebody's looked at that as well in dialing these things up.
It brings to me the idea that to bring all the resonant frequencies together, that it's going to cause something to open up, something to there. You'll crack a barrier, and I don't think it's going to be a smooth opening of the barrier. I think it's going to be a crack, and I think we're going to see energy, and I think we're going to see energy from the 0 point. As I read more about 0 point energy, from a patent from an engineer that works on UAPs. What you're describing just sounds, it sounds like you're doing it, what he's doing, but in a different way, because he's trying to condense plasma with magnetic fields. But man, you're just shaking that crystal to its deepest existence. I mean, you're not playing around. You're causing that crystal to just, oh my goodness. Hey, we just lost you.
No, I'm good.
Okay.
Sorry.
Did you decide to go because I was rambling?
No. This camera's been freezing. I got to replace it. I got a second one. I got to switch them out.
Okay.
Yeah, I think one of the things that's lost in this, Shawn, is nobody's done it. So they all have opinions on it, and everybody
Right.
thinks it works one way or the other, right? But the defining proof is the build. And
Yeah.
like you know what I mean? Throw everything at the wall and see what sticks.
Right. Yeah, I'm just going to say that that's going to be a big win if you can do it. I mean, I'll say it this way. If anybody can do it, you can do it.
My biggest concern is that it'll be in the hertz. You know what I mean? Not the kilohertz.
I know.
So
Yeah.
I'm going to be having some giant coils. You know what I mean? If that's the case.
Right.
So I'm just going to, I mean, it's going to sound bad, but I'm just going to pull out some 20 gauge magnet wire and wrap these things in it, because it's going to take a lot. Maybe get a 6-inch pipe to start with or something like that. It's if it's in the hertz or the low hertz, it's going to really need to be kind of a big deal.
So that's why I want a 50,000 wire coil, because the inductance will be so high that the resonant frequency is going to be super low. And I'm trying to get into that hundreds of hertz. And I 15,000 hertz is right now my lowest point. And of course the ZBS, I mean, you can rule the world with the ZBS, but it has limits. It has low limits and high limits. And so what kind of oscillator are you going to get into the low hertz?
Slayer Exciter.
Ah, interesting. I got to write that down. How do you know this? How do you know this? My goodness, brilliant. I'm just going to take notes here and listen.
Well, there's no time for playing around and messing with the ZBS. I'm not looking to shoot super amounts of power. 10 volts or less, Shawn. That's what I'm looking for. I simply want the reaction. That's all I'm looking for doing this.
Of course. Oh, of course. If you can just get it working.
Yeah, see?
Yep, exactly working.
Well, see, here's the thing to it, too. I'm not putting power on every coil. I'm going to put the power on one coil. The rest will just be secondaries, yeah. The rest will be secondaries just sitting around the table. And I'm going to go quarter, half, third, eighth, you know what I mean? Different waves, you know what I mean? Because they'll match the frequency that you put it through the oscilloscope there. And I'm telling you, man, we're going to have a whole cool thing. My Slayer Exciter circuit's awesome. So, you know, it runs all day. Yeah. So I'll be able to mess with it, play with it, tune it. You know what I mean? There's no issues there with it burning out.
Yeah.
But that's the way to go. If it kind of proves a point. If I can ring it at half Tesla coil, then that's normal. We've seen that. Okay. Yeah. There's no discussion there. If I can ring it at a quarter, people don't usually see that. If I ring it at a third, you don't usually see that. If I ring it at an eighth, you never see it. You know what I mean?
Yep.
But then
Exactly.
if I put all of them around this thing and I ring them in a circle, or I ring them in a, maybe I just put it in a configuration of a golden ratio and I turn it on.
Yeah.
What am I going to get? That's
Right.
what I want to see.
And when you're saying matching it to the frequency of a crystal, what kind of crystal, what dimensions, roughly, what do you have in mind?
Well, there's a couple of them, and forgive me, I can't remember the name of the one. Something night. It's white and it's really breaks apart really easily.
Mm-hmm.
There's that one, and I have quartz. So I have two gigantic boulders of each sitting in my front yard that I just take off of, and you know what I mean? I'm just gonna take them out, and like I said, I don't need much, and I just need to bash them up, put them in a container with some water, and I'm gonna pull the frequency when they start putting out voltage. They'll put out 0.875 or something like that in volts.
Mm-hmm.
And so for people who don't understand this, if you have voltage and amps, you have a frequency.
Yeah.
So I'm just going to put in the thing and check the frequency.
My guess is, I mean, you can answer this, would the cracks in the crystal make it more difficult to find all the different frequencies? Wouldn't a clear with no flaws crystal simplify it for you and not have so many resonant frequencies?
Well, here's the way I'm thinking about it. It's going to put off different frequencies, yes.
Mm-hmm.
The more frequencies it puts off, the more I can fill in the pattern before I even start. You got to remember, I'm going in with a hypothesis that we're going to have at least 6 different frequencies.
Mm-hmm.
So if I can pull 3 out of it, then I just take them and I put them in their spot, and I find the relationship between them.
Mm-hmm.
Are they 20,000 kilohertz apart? Or, you know what I mean? Is there an equal run to each one where I can build a pattern faster? See, if I get one, then I go, well, which way is it? Do I go up? Do I go down? You know what I mean? And it's going to be a guessing game. But if I can get 3, I'm like, whew, boom, we got a pattern going. And I could tell just, you know what I mean, by each one of them, the ratio, and we could figure it out quick.
I think that's inspired. I think it's I have so much on my plate, but I want to do it too. But it's on my project list, and it'll probably get pushed up because the idea, oh man, I've always wanted to get into, and I have a whole box set up for it of different kinds of microphones and speakers, because I wanted to be able to find the resonant frequency of different objects and then have the Tesla coil run at that same frequency. But it's super not easy to do. And I have so much other fun stuff I'm playing with, and my health, of course, limits me a lot. But that's just me getting the Tesla coil to one object. You're thinking, no. I'm going to break that coil 2 down to its harmonics or sub-resonant frequencies. Then I'm going to get to run at these crystals. Oh my goodness. Yeah. Oh boy, that's going to be hard. It's going to be cool. Even if it doesn't work spectacularly, man, we're going to learn so much from it. I'm just going to say it. We're going to learn so much from it.
Well, this is the next step in harmonics and putting it all together. I mean, you can get coils to do this kind of thing, and that's what they're meant for.
Mm-hmm.
But to break it down and test the coil so everybody can see it, that's really what we need. You need to be able to see why it's doing it.
Yeah.
So I think it's gonna, I don't know how to say this. It's gonna change the way we look at everything. And then if we take the microphone, remember when I did the live experiments and you could hear the different sounds?
Right.
So I'm gonna take that same microphone and do it to this so that we can hear each one of them. And each one of them should sing. As soon as
Yeah.
they hit the resonance frequency, they should start singing.
Right.
So we may have like a whole orchestra, you know what I mean, going off
It's
at once.
so smart. Yeah, I mean, I can see it. I can
And
totally see it.
so then the question would be, is the timing preset? So because they're built in, you know what I mean, eighth, you know what I mean, stuff like that, and it's a
Yep.
fractal going up, is it going to preset the timing? How long does it take to get to the next level? You know what I mean? Each time, is it going to preset that timing where the harmonics go 1, 2, 3, 4, 5, 6? You know what I mean? Just right after each other without changing the primary running circuit.
Right. It's gonna be what's the frequency of jumping to different frequencies, and will that frequency affect the other frequencies?
Yep.
Yeah, you could call it the jumping frequency. Is that going to affect the natural frequencies? Interesting. Yeah. And if I guess maybe they cancel themselves out, if which would also be interesting. I wouldn't say that was a bug. I would say it's a feature because uh, I just want to see this. It's funny because I'm so into what you're doing in this idea. I'm so into it. I have all kinds of metal objects and glass objects that I buy from the thrift store. My wife's always going, "What are you buying that for?" Because it spins. Because I hit it and it puts out 10 frequencies. And I'll walk around my lab and just make sounds and then go to work. Because there just seems some like a relationship between the frequencies around us and thinking and ideas and exploration. There's just it's almost like an orchestra. And I know I'm sounding really cheesy, but it just seems like music. And
It is.
yeah, awesome. We got some guys in the chat.
Oh, by all means, get in there and check out the
Yeah.
questions.
And guys, if I don't get your questions, I apologize. You guys have so much good content. I pretty much try to get to your questions, but it's not easy talking to a smart guy like Nathan to then jump to these. So, so Michael Merrick mentions notable piezoelectric crystals. He says one Rochelle salt, which is a potassium sodium tartrate. Strong piezo response, but less stable. 2 is that tourmaline, durable and stable, but with a lower piezoelectric. That's good stuff. Yeah.
Yeah.
Let's see. Time Energy says, coming from any bifilar runs with a square wave. I don't know a lot about bifilars. I do have a sketch of. I'm going to use the bifilar I'm winding as an oscillator first because I want to do a lot of playing around with it, and then I'll start thinking about how Tesla used it. Now, the square wave sounds interesting. Have you heard about something with a square wave and a bifilar, Nathan?
You know, I don't mess with a lot of bifilars at this moment. So square wave and a bifilar just means you're running DC in it.
I mean, yeah, it depends on the low. If it's below 0 or at 0, yeah, it'll be DC or pulse DC. Yeah, makes sense. So Michael Merrick says coefficient, then quartz. He says lead, zirconate, titanate, a synthetic ceramic with much stronger piezoelectricity than quartz, but is not natural on a natural crystal. And then there's barium titanate. So it seems like Michael Merrick is a piezo expert. That's awesome. Let's see, synthetic option with high piezo response. Let's see. Creative Studios says jabber dropping epiphanies. Yeah, Michael Merrick knows his piezo. So John Bigman says, remember Floyd Sweet conditioned a magnet by a coil within the bottom of a Tesla secondary coil with a magnet on the top of the secondary. That's interesting. I've tried to play with magnets and the Tesla coils, and it acts just like metal next to them. I'm setting up a powerful magnetic field that I want to see if I can bend the plasma. So I'm working on that. If you guys are interested, I think it's called a bitter coil, Bitter, and it puts out the strongest magnetism. You have to run electricity through it. But yeah, I want to point it at my plasma and see if I can start controlling it. Because if I can bend plasma with a magnetic field, that means I can condense it.
Mm-hmm.
And if I can condense it and I can get enough intensity of the plasma, I really believe that's going to open up doors. I really believe that.
Nice.
Dead Fish says, all the fire made shards that made up a bigger crystal, and the flames burned down towards the ground, but not like a jet, more like a campfire. I think they're talking about something else. So Jabber says mica is a great as well. They made ceramic caps out of it back in the day. Bet it's highly piezoelectric as well. Boy, I can talk. So I've not heard of obsidian. Is that what he's saying here? Obsidian? Mica. I haven't heard of mica having piezo effects. Have you?
More of a, what is it, a dielectric or a...
It's a brilliant dielectric. One of the best.
Yeah. So I don't know about the piezo effect, to be honest with you on that one. Everything's worth testing, man.
It is, and for some reason I love mica, so it works so well. If I need something, if I have two wires touching high voltage and I don't want them to touch, I'll slip a piece of mica between them.
Nice.
Because the mica sheet is not going to let electricity go through it very easy, not even high voltage. So, or if I'm soldering on something, just put a mica under it. That way, mica will hold the heat with you, but it won't damage under it and won't damage it. So these little thin sheets of mica, I use them everywhere.
We were talking about the ring and stuff. Well, I wanted to share something with you, Shawn.
Okay.
So I took my little Bifilar and I rotated the disc on it, right?
Mm-hmm.
So I don't know if you know this, though. I rotated the top one at around 1,400 RPM, which is kind of slow.
Okay.
But then the bottom one, I started rotating about between 600 and 800 RPM. Each one sung individually, but then the capacitor in between picked up power as soon as they started to sing to each other.
Oh, wow.
So that's kind of why I came up with the thing with the Tesla coils as well, because there's a unique relationship there. I just thought it'd be interesting to share that with you.
Yeah.
You're talking about things singing. You have to put your mic right to it. I'm mostly deaf. I can't hear it. But when I put that mic to it, I can hear everything. And then it started singing back to my ultrasound, which is a modified Joule Thief circuit. And it started ringing in that thing too. And I'm going, okay, this is amazing. Like, I don't think anybody's ever heard that.
No, that's great. Wow. Are you making a video on that so everybody can? That's so cool. That's so cool. Hey, I have an idea, guys, in the chat. If you guys want us to ask a question or read your comment, could you put my name or Nathan's name in it? It's easier for us to scan, and we can jump on your comments. Dennis Matovich actually did it. He says, Shawn, do you remember the name of the product you mentioned using for fields? It was from an aquarium cleaning product line.
Oh yeah.
Yeah, I'm gonna go grab it real quick because I can read it to you. It's right over here. Yeah, I was gonna share with you some cool things I figured out on how to see invisible fields, Nathan. So it should come up pretty soon. So it's a little container like this. It's let's see how many ounces. Potassium permanganate. Let's see if I can get it on the camera here.
Nice.
Potassium.
Yeah, you're kind of going off the side. Go back in the middle.
Sorry, I'm dyslexic.
Huh.
Can
No,
you
you're
see
good right there. Yeah, everybody can see it.
So I keep turning it the wrong way. Here we go.
You're good, Shawn. They got it.
Potassium permanganate, 8 ounces. It's not cheap. It's not expensive. So I have 8 ounces. 8 ounces is a lot. I mean, a lot. It'll probably last me a long time. So you don't need more than 8 ounces. If you can even get half of 8 ounces, because it's a little pricey. I mean, I don't want to spend $30 on a little thing of powder.
Mm-hmm.
Um, so I think this is $15. So, and so the way I'm using it is I have a flat surface that's a little bit absorbent, and then I sprinkle a little water on it. And then I put the electric field. So I'll take like the positive end of a high voltage wire, put it on top of the flat surface with a little that's damp, and then sprinkle the powder, the potassium permanganate, that word, and then you'll see it'll shoot out lines showing you how the field is straight, bent. It'll show you how the electric field looks.
Hmm.
So and it's pretty cool because I'll take a teaspoon of it or a super small amount, and I'll bring the positive lead to it, and they fly out into eternity. I mean, I can't find one anywhere in my lab. So they're really reactive to fields. So it's worth looking into. All right, so I'm looking for my name in the comments so I can read it.
There you go, Shawn. They also known as what? Condys crystals, CONDYS crystals.
Guys, I'm gonna write that down. COND. All right. Thank you for that. I'm not seeing Nathan or Shawn, so you guys are having a good conversation.
It's all good.
It's so fun. There's 48 of us all across the planet, and we're all together, like-minded, talking about cool stuff. This is just
Absolutely.
too cool, too fun. Let's see. Michael Merrick is the guy when it comes to crystals. Man, he knows his stuff.
Yeah, I think he wrote a novel tonight, like with all the comments.
Merrick? John Merrick? Yeah, it's
Michael Merrick. Yeah, you wrote a novel in there. I'm gonna have to go back and read the whole thing when we're done.
yeah. I'm gonna try to see if I can copy this because I figured out a way before how to copy these, and I was able to read them later.
Here we go, Shawn. Let's see. I'm planning on using mineral oil and mix the powder for a simple ferrofluid sample.
That sounds sound. That sounds like it would work. I've never tried it, but I know you can put grass seed in mineral oil or baby oil, and the grass seed will form to the fields. It'll show you how the electric fields are formed.
Hmm.
So, but I never thought about putting this potassium stuff into mineral oil to make a ferrofluid. That sounds fascinating. I'm actually going to write this stuff down because I'm going to forget.
We got to do some cymatics together, Shawn. Got to get a speaker and put some ferrofluid in it. Make a little cup or a petri dish in the center, and then run different frequencies in it, and just watch it. You know what I mean? Change shape and everything like that. That'd be a cool video between the both of us.
Have you seen it? Have you done it before?
I've seen it on YouTube. There's a guy that does a beautiful job of playing a song and going through all the things. He's got some fluids in there.
That would be
Man,
cool.
he's got some stuff that looks like mercury, everything. And he was playing, a song with it. It was just absolutely brilliant. So I think something like that might be cool.
Sounds good. I see my name here. Michael Merrick says Shawn forgot to add that.
Oh. Shawn isn't permagnetate. Yeah, from under the ocean. Sorry.
Permag. I should have done more research. I apologize. I'll have to look that up. It's a good question. What is it made out of? It's used in aquariums. That's all I know, and it's super reactive to fields.
I want to see Ken does something to see magnetic fields, and he puts he calls rat juice or bug juice in there, and he puts like a drop of blood, and then he puts it between two slide plates for your scope, right?
Oh,
and what it does is he puts it right over the magnet, and it shows the fields in it.
yeah.
And I thought, like I said, Ken does that, and I thought it was so awesome. He's like the master of magnets. So what I want to do is take a curved lens, do the same thing to it, and then throw it on the end of my camera. You know how they have the lens cap that you can put over the lens?
Yeah.
And it's curved for sunshine? I want to do that and see if I can't pick up at a distance that field.
That sounds amazing.
Yeah, I thought so too. I got to look up the exact juice he uses, but if it does it, man, that's revolutionary to see fields in the middle of nowhere. There's also the curved mirror effect that you can use that picks up everything in there. And those are the things that I was looking into with Joe, because we got to start seeing these fields somehow.
I know.
I think there's more going on than what we're seeing. And if you see it once, it'll be like a whole new world.
Right. I agree. I totally agree. That's why I've been searching too. Dennis Matovich says, Shawn, I'm planning on using mineral oil and mix the powder for a simple ferrofluid sample. I think I just read that. Apologies.
Yeah, you did.
The thing I'm thinking I'd like to do is, because this potassium stuff is so reactive, what if I put it between two thin sheets of glass with a little water, and then touch the field, the high voltage probe to it? Because if it wants to leave when it's dry, it just wants to get away from it. If it's wet and I touch it, it might sort of splatter out, and it'll show me the direction of the field lines. I just got that idea from you saying about the guy seeing fields. So awesome. Good stuff. Good stuff.
Okay, hold on real quick. I just want to put this up. All right, we might already have an answer to seeing the fields, but time will tell if it works in the application. That right there, Jeremiah, would be revolutionary. If you get it, I know somebody's going to patent it, but when it's available, I'd like to see it.
Yeah. It's incredible. Jeremiah. Hey, Jeremiah.
Yeah, if somebody gets that, you better patent it, because every scientist in the world is going to use it. You might as well make a few bucks. You know what I mean?
Yeah. Anytime Jeremiah talks, I go, wow. He's smart.
Pretty smart, man. Yeah.
I'm the dumbest guy in the room when I'm with him.
I don't think that's ever true, Shawn.
Oh my goodness. You are too nice. Too nice. I'm just a good faker. All right. So I tried to copy the text and now I screwed up my computer. Bummer. There's so much good stuff. All right. Ian Jackson asks, Shawn, are you familiar with Norman Wooten's lectures? No, I'm not. Norman Wooten's. I'll have to look him up.
I'll tell you what, Jeremiah, I'm going to take you up on that. If I can map them with the radio, I can see them with the fluorescent lights. But if you got another way, I'd love to see it.
Oh my goodness, yes. Teach Nathan, and Nathan, you teach us. Oh my goodness, that would be great. So, Mr. Lanius, nobody knows who he is, but he says Captain Shawn.
Mr. Ladies, you know that's Jarvis.
Jar Jar. I know. Just
Oh.
teasing. You know, I'm not going to answer your questions, Jabber, until you put my name in.
So I got to mess with him a little bit.
Yeah, Jabber, he's awesome. So I found out where I forget what, I think it's Brandon Co. I found out, you know, he lives in a giant island off of the north of the Atlantic Ocean on the north side of Canada on a giant island.
Really?
I didn't know that. It's the coolest place.
We're talking about Brandon Coyote?
Creative Studios?
Yeah.
Yeah. He lives out in nowhere.
On an island.
It's awesome. It looked cold.
No, he sends me pictures all the time. It's freezing out there.
Yeah, we were talking about tractors. He was showing his brother because I have a tractor, and when I get on my tractor, you cannot take the smile off my face. It's just fun moving dirt around and digging, and it's just I never knew how fun it would be.
Did you buy the farmer's hat for the tractor?
I do. For the hot sun, it's a big straw, kind of a straw hat.
Yeah.
Yeah. I got a deal on it. It was the last one for the year, but I had to pick it up in Tennessee, and Tennessee's an 8-hour drive.
Oh wow.
So I went down there, paid way less for it, no taxes because
Nice.
they have no sales tax in Tennessee, and which is immense for a tractor. And I drove it back, and yeah, crazy. All right, Mr. Lanius says he is a genius. Okay, yeah, we know that. No, he's talking about Jeremiah. Man, Jeremiah needs to come on and teach us. Michael Merrick says screenshot it. I would, but I'm not quick on my feet. So that would be 10 things to do while I'm talking with you guys. But I need to figure out a better way. And YouTube changed because I was able to do it before. You could click on a comment, hit Control A and Control C, and then Control V into a Word document. Boom, you had everything. No, they stopped it. I don't know why they don't want you doing it.
Wow. Always something.
Yeah, always. Apple does that. If you have an Apple phone and you send a video to somebody who has a Samsung, Android kind of phone, they won't get the video. But now when Samsung figures it out and fixes it, then when you send an iPhone video, it's perfect. But then when Apple finds out, they change their iPhone and then Samsung doesn't get it again. So I don't know why I'm saying that. It means something. All right. So Brandon says, Shawn, seems many of the same principles carry over into hydraulics, very similar to electrical. Yeah, Nathan, what was your thoughts about how the gas in the glass spheres, turned into those probability clouds at the atom level? But of course, there's millions, trillions of atoms. What was your thought about how they were almost like the same as when it was at the microscopic level?
You're working on the Planck scale as well as the planet scale. That's what you're talking about when you're talking about the gases.
Yeah, it's because I saw Neptune, then I saw probability clouds for electrons, all in one little sphere. It just, yeah, exactly. You said it really well. What were your thoughts on that?
Well, they all have every planet that has any kind of atmosphere on it has some kind of a plasma. So there's going to be discharge like that when you interact plasma with the gases on any planet. So it would make perfect sense when you're dealing with stuff like that.
Yeah, I just never thought of it, I guess.
Probably why NASA goes out there and they image these planets and they tell you what's on them because
Yeah,
they're getting a reading back that's like that. And then they're able to decipher what the gas is in there, what the reactive level is, so they can tell you the volume of it.
right, right. The When I looked up for some reason, when I lit up the helium, I immediately thought of Neptune and Uranus, because they're my favorite planets, and because I love the blue giants. There's just something fascinating about them. And the picture that I shared was uncolored, so they
Yeah.
touch up photos so you can see them.
Mm-hmm.
But when it's not touched up, is when it matched completely to the helium sphere. So I thought that was fascinating too, that it really was a representation of the planet, untouched. So Cheris Rosen says, Captain Shawn, I'm curious, what does that mean, Nathan?
Oh,
Right? Huh?
so we do the emojis, right? And there's my emoji's in there, which says Captain on it. It's the label that it says. Your
Mhm.
emoji says Shawn. So there's, when you look at it in the chat, it shows a picture of each of us. But when it's shown in the display here, it'll
Uh-huh.
show it as the word that's associated with it. So mine says
Oh,
Captain, yours says Shawn.
so I'm looking at my iPad now, and so it's making sense. I can actually see the icons. Sorry, in the administrator view of what we're working in here, you and me, it's just these weird underscores everywhere.
Yes. Well,
Ah,
that's what it is. I love emojis. I love everybody to participate. Throw them up when you got them, man. You know what I mean?
it's
It's
so cool.
it's a great way for all of us to interact on the chat and have fun. And when somebody presents, you usually find me in there putting up all of them and having fun in the chat. You know what I mean?
It's so cool. It's really interesting. It's very colorful and interactive and super cool. So Ian says, Shawn, Norman Wooten was the guy who replicated from recovered missing stuff some of Tesla's stuff and Ed Gray's. Oh, so he recovered Tesla and Ed Gray's stuff that's missing.
Hmm.
Hmm. I'm gonna write that down here. I hate to look down when we're on the live stream. It seems rude, but that's the only way I can do it.
Do what you gotta do, Shawn.
Thanks. Let's see. Exotic Propulsion says xenon is insanely expensive and very important in dynamic plasma energy conversion systems. Huh, I didn't know that. Thing cost me $40. Oh, it was, I just, I handled them with special gloves and I don't want to hurt them. They're so cool, though. Thank you. Jarvis said it was awesome, Shawn. Appreciate that. Plasma is cosmological. Yeah, it's the most common thing in the universe is plasma. I don't know about it being the third state or the fourth state of matter, though. I don't think it is. But I mean, I know I'm wrong because everyone on the planet believes that it is the fourth state of matter, but I also don't believe the speed of light is the speed of light. So
Well, I don't think anybody in their right mind thinks that the speed of light's constant.
yeah,
It's something that they threw out there and they never corrected.
right.
It can't be, because light has different colors, and for every color it means that you have more amperage in it, which means you have a slower thing, and you got some that are faster when it comes to light, because that's how they get built. You have, you know what I mean, energy. Next, you got frequency that comes in contact with the magnetic field and it produces light. But as it produces light, with the more energy that you put into it, it starts to go into a plasma state. Then the plasma state converts into a solid state. You know what I mean? So you can see that how it goes into transmutation in order to make a solid out of light. Yes, but it goes further back than that just a little bit in order to go through all of it.
When you say make a solid into light, is the opposite, because right now currently it's the solid that emits light. So electrons give out photons, but you're talking about photons making electrons. That's crazy, and I've never heard of that.
Think about it when you build it in your lab. I mean, how many times do you get the whole rainbow when you start turning on like a DC flyback, and then you can control the amount that goes in, or you just control the voltage, right?
Yeah.
As soon as you turn it on, you get like a nothing state, which is clear.
Mm-hmm.
Then you move on to a purple state, which is really, really dark purple when it has less to it. And then it gets lighter, and then it moves into a pink state. Right. And then as you go more, you can get into a yellow, and you can get to white. So if you go cold, you can get to a blue. And then as you build them, then it starts to build into a thick, usable plasma as you keep going. So
are you saying matter is slow plasma then, in rough terms?
It feels that way when you start building it out in your lab. That plasma is the conversion state. It's what's taking your light and converting it to matter.
That's on my list. Transmutation has been very fascinating to me. So, I mean, that makes sense. When I say I don't believe the speed of light is the speed of light, is because we don't measure the one-way speed of light. We measure the two-way speed of light. The light goes out, and then it comes back, and then they take the average of those, and that's the speed of light. And all of physics is based on that, the two-way speed of light. So I don't believe then that the one-way speed of light is the speed of light. I believe the one-way speed of light is infinite. I believe that light one way is instantaneous, no matter where it's out in the universe. And then when it bounces back, then that's the two-way speed of light. I say that it is half of the speed of light. And if you do the math, half plus infinity, you get the same speed of light that we have today. So it does not break physics. And it's a way better way to look at it, because if you look at light in the universe, things start not making sense with our current models of how light works at the speed of light. But if you look at it from the one-way speed of light is instantaneous, and then the return trip is half, and then you take the average, you add them together, take the average, and you get the speed of light, that changes everything. That means the star that's 1 million light years away, we're watching it being destroyed, or we're watching it go into a black hole. We're watching it real time. And no one can disprove that. Einstein in one of his papers wrote, I write the one-way speed of light this because otherwise I don't know what to do with the math. It's just a placeholder that you have to
Mhm.
fill it in. And the problem is you can't figure it out without using the current speed of light model. That's the thing you're trying to disprove, but you need it to disprove it, and that's the problem. So, but I'd love to work on that. That was what got me into this hobby. I was going to entangle two particles, and then I was going to prove that the entanglement was instantaneous as a catalyst to determine what the one-way speed of light, and to prove that it was instantaneous. But then I met a great guy, got into Tesla coils, and over a year ago, I couldn't spell Tesla coil, and but we had fun together, and now we're here.
Yeah.
So, and guys, listen in the chat. Nathan talked about we're going to kind of do biographies and just a little bit of background on each other, if you're interested, and then talk about how our experimentation on what we're working on and from start and how it's evolved over time. So you're not going to have to sit and watch 8 hours of our stuff, but just highlights. Hey, I started here. I learned this and got here. And then Nathan and I, and so on. So that's in the works. And I'd love to hear your feedback if you're interested in such things. But I know Nathan had that idea, and he was talking about us in the pre-show prep.
Yeah, I think it's an awesome idea, Shawn. I think it gives people an understanding. Look, we all start with humble beginnings, and then we all build something, and then we learn relationships and how to build things in our products, and we make relationships with people and get stronger ties as we, exchange ideas.
Exactly.
And it kind of tells you how we all kind of came together as a community to figure things out.
Exactly. Yeah. I'm a high school dropout, and that surprises people because they thought I dropped out at junior high. But I said, no. I dropped out at high school. That's a bad joke. And for some reason, it encourages people. Oh, you dropped out of high school? I'm like, yeah, it's put your mind to anything and you can do it. Don't put yourself down.
Yeah, they could have cut out most of high school. I mean, 1 year for what they teach you in there.
Yeah. I just learned algebra. I just learned fractions. And yet, I was a corporate executive. I was data architect, infrastructure architect. I managed 5,000 databases across 2,000 servers for Pfizer and Merck and all the big pharma companies. I managed their data. I mean, I have some really big things that were great to do, but I haven't done a fraction. I don't know algebra. And I cheated because if you learn computer programming, it'll do everything for you. That's the thing. I got good at programming, and then it just made me look smart. So, so
Shawn, I used to own a cabinet shop, tape measure fractions all day long, radiuses, done all of it. I taught my son how to do geometry and algebra 2 in the same year within 4 months.
wow, that's my wife.
And he passed his classes, man, no problem, on a home study. So,
Wow.
yeah, look, I like math. You know what I mean? It's simple. Put out a formula, follow the formula, and you're done. Replace the letters with numbers.
Yeah.
As long as you know what it is, and it's pretty much straight arithmetic after that, no matter what you're doing. Sometimes you got to push a button in the calculator to get a sine or a cosine or something like that. But
yeah,
other than that, man, they make calculators so easy these days. It's like just pay for the expensive one and get all the buttons.
yeah, no, that makes sense. Total sense. My wife and my daughter are mathematicians. All my kids are all mathematicians. And being dyslexic, I had to come up with kind of my own math because algebra was just too. I mean, I just learned algebra a couple years ago. I learned algebra in my 50s. Yeah. Oh, teach a dog an old dog new tricks. Ooh, I'm the old dog.
Oh, yeah, that's awesome.
Jabber says, Shawn, sphere are great in holding charges. Pointy stuff is great at dissipating charges.
Hmm.
Great presentation, Jabber. You're awesome. You're totally right too. And that's important to note that a single point is a dissipating charge. What I say is you're tricking the electrons. Electrons don't like each other. So if you trick them out to a point to the end of a wire and there's a whole bunch of them, well, they're not hanging out together, so they're going to jump out into the air and look for protons because that's what they desire. Um, but the sphere holding a very consistent charge, that's true, but it's hard to manage on a ball. I figure out a point, it's easy. But have you ever tried to put a high charge on a sphere? It starts electrifying everything, and that's why it's hard to do. I get I get a quarter of inch arc from my finger to the button when I charge spheres. And I go, what is going on? But if I have the Tesla coils that you saw and it has a little pointy wire, then I'm controlling it. So I have a little rubber ball at the end of the stick to hit the switches when I'm loading spheres. I don't know if you've had that before, Nathan.
I don't deal with spheres that many times. I just got one for my device that I built, and it's going to be the first time I'm rotating a sphere. So,
Yeah, you haven't printed any of my grouped coils yet, have you?
I haven't. I haven't. I've been so busy.
I mean, I think you'd because you're the plasma whisperer. I think you'd find something that we did not think of. I'm just
Oh,
saying.
I'm sure I find 100 things. To be
Yeah,
honest with you, I'm kind of looking forward to just sitting down one week and just getting the STLs and start printing them off and doing them. I
yeah,
just need the time in my schedule. That's it. It's, between doing the interviews, doing all the live stuff, and then I have projects I'm working on, and I've been down for a while.
yeah.
So
Your health issues.
yeah, I haven't been up and getting around to do everything. So I kind of want to complete some things, and like I was telling you before, I want to get it all together and put out a video a month on what I'm doing on my personal project,
Hmm.
and then just do one a month, so I'm not pressuring myself and not forcing things or anything like that. That way, I can make a nice, clean, concise one video, not a bunch of little videos, and then just change the way I do things, because right now it's taken so much of a toll on what I'm doing. I don't get to enjoy myself doing the coils.
Yeah. So that's good for the guys in the chat to know is you're moving to a different model, and that is you're going to have these um, panelist live stream presentations, but you're moving to putting out one of your videos a month of what you're experimenting and working on. And so in dividing those two and putting it in that kind of schedule is going to give you enough where you're actually back to enjoying and not burning the candle at both ends.
Yeah,
So
because a lot of times I put out the stuff as it comes out, but it gets real confusing for people. I noticed that, you watch one video, you miss one video, you watch another, and you get the questions you answer in the video they didn't see. So it's better
that's
to do
smart.
like a plasma channel model and put
That's
everything together and send it out.
total sense. Makes total sense. So Ian Jackson says, Nathan, how do you send an image for an emoji?
How do you do it?
That's Ian Jackson's asking you.
Oh, well, I just go over to Canva and make them. Like if you put an image in Canva, you set it with a circular design on it, and then I go through a couple different imaging processes. that wipes out the background, wipes out, side parts. I'm able to clean it up. And then usually there's a ratio involved. So it gives you very bad pixelation is what it is. There's a program that'll actually do that for you.
Mm-hmm.
I kind of hit and miss. I throw it in there and see if YouTube accepts it or not. Because I'm cheap and I do not want to pay an extra $10 a month for an emoji program. And so a 50-50 shot, and I know the more that you put into it, the harder it is to get it done. So I try to make it with very few pixels.
So you made these emojis?
Yeah.
That's so cool. You're using the one that you put me in the spacesuit? Is that the one?
Yeah.
They look professional. I thought you bought them, or I don't know. I thought you used some expensive tool.
No, you know me. Everything I could do that saves me money, man, I have to do.
Yeah, that's great.
I take all my nickels and dimes that come in, and I buy products to build more things. You know what I mean?
Yeah.
That's kind of what I do. I'm in retirement, so any money I get goes towards all the projects that you see.
Yeah.
So.
And you're saying that you put the membership money, which I really hope you're able to jump in and join Nathan and these experiments and become a member. It's a very low price, but it goes for what Nathan says. It goes right back into the channel. It goes back into the inventions that he's working on, and so yeah, I'm gonna put that shameless plug out and say join the team.
I appreciate that, Shawn.
It's Nathan, I'm telling you, and everybody knows this. You're doing such a good job. You're putting in so much effort, and it's a place where I don't like the term safe space, but it's a safe place for ideas, the free flow of ideas. Where does a garage inventor go? Where does a guy he'll mention, you're not using the exact words, and people who have degrees in engineering will say you don't know what you're talking about, but I'm building stuff and they work, and I'm learning stuff that aren't in the textbooks. But that's what you've done. You've made a space for that. And even the spaces that are open to this free flow of ideas, there's still a little snootiness in there. But there is none of that on your channel. No. You're literally saying, hey, talk, it's your time.
That's right.
That says a lot. That says a lot.
Well, you know what? It was bound to happen sometimes, man, because we got to get our voices out there and get heard. Not all inventions are made by scientists. They're made by garage inventors, things like that. Some of the best ideas are made by people that have nothing to do with science. They just see the world differently.
Yeah.
And that makes the biggest difference, because it's not always your project that people get everything from. Sometimes you just pick out a little part of what you did and finalizes their project. So that's why sharing is important.
Yeah.
Like I may use a driver circuit that just blows you away, that would change your product, your whole thing. When I change the frequency of whatever I want on my plasma, that might be just what you need.
Right. Yeah. It's I shared one of my presentations because I've sort of learned the vernacular of the fringe science, where we're all just using plain language. And I sent it to a friend who has an advanced degree, and he knows that language, and he said, I didn't understand a word you said. I said, oh my goodness. But he did say thanks for sending it. And that's fine. I mean, I asked my wife, I said, maybe I'll wear a collar, a nice business shirt in the presentation today. And she said, no, you won't look fringe.
That's right.
All right. I'll put on what's comfortable. So yeah, she's 32 years of marriage. We still giggle like teenagers. It's an awesome thing.
Well, you know what, Elite, she stands behind you in what you do, Shawn,
Yeah.
and work together as a team. You can't ask for anything more than that.
No, that's exactly right. With my health problems, it's hard to get a hobby that is outside the house and that's predictable. It's why I miss Wednesdays because it's tough with my health. But I'm telling you, there's no guilt trips. There's no, oh, well, you missed it. No, it's just, hey, we're glad you're here. And we're all in this together. I will say, though, like I shared with you before the live stream, there's a lot of like affection in this group. I mean, everybody's arm in arm. I mean, there's a brotherhood or sisterhood. It's not just acquaintances, or this is a really cool thing.
Yeah.
And people are saying 100% in the chat, so I appreciate that. And it's just true. It's great, and we're all going in the direction that hopefully we can come together and do something big.
Well, that's why we're changing the way we're experimenting, right? Like
Right.
normally you go, we got to test the coil, it works, and we're all happy, and we shoot some sparks out of it, and we call it a day. That's not what we do. We
No.
push the envelope. You do geometry in it. I'm bringing different frequencies in it. We're taking secondaries and lighting them up from across the room with some plasma. It's much
Yeah.
different. We're just pushing the envelope where other people haven't pushed it. And let me just share something with you, Shawn. When we had Liz on, we were talking about Atlantis and stuff, and the technology they had there. Every time she talks about it, it's vibration, it's frequency,
Yeah.
it's dialing it in like a safe lock. There's
Yeah.
different frequencies that intertwine with each other to do different things.
Yeah.
And it's such a revolutionary concept that has been right in front of us, and we haven't been able to pull it off yet. And I think that's where we're headed. We're going to kick that door down, man. We're not even going to play with it. We're getting to the answer that everybody wanted all along. That it doesn't matter if you're an engineer, a physicist, anything. That's the answer you wanted. Even if you didn't know you wanted it because it's the whole key to this world. It's how everything works. And I honestly believe, man, by bringing everybody together, we're going to get there. Because I'm going to tell you right now, I'm not going to see everything in my project.
Yeah.
I'm going to need help. I'm going to need everybody seeing it and tell me what it is. Because, man, it's going to be something that's going to revolutionize everything.
And when you share your thinking, even it just causes domino effect of, oh my goodness, I never thought about it that way. And then they're going to put their own flavor on what you're doing. It's totally all of that. It's great. There's a book called Outliers. So if you guys don't know this side of me, I've read many books. I'm a book nerd, and so one of them was Outliers, and it was trying to research how does success work. And so in the 1930s, they thought, I think it was 1930s, they thought if they got the highest IQ kids, the smartest kids in the world, they put them in one place and they were taught by the best teachers in the world. And I mean, you had to be such high IQ on the tests that if you were 1 point below, you wouldn't get into the school. And so they said, all right, these guys, now they're grown ups and they're going to be set free. They did nothing significant. We didn't never heard of them. But two kids that they rejected, they weren't smart enough. Those two grew up to win the Nobel Prize in physics, because that's not how success works. And it's mind-boggling. And so to save you reading the book, basically what they tell you is you need to put in 10,000 hours. If you put in 10,000 hours, you become an expert. You become the highest level of achievement in whatever you put the 10,000 hours in. and then so I really believe that the intuition is the 10,000 hours. You just start to, I put in my hard work in these things, and all of a sudden now I really know what they're doing and how they're feeling. Because I know a lot of it, like I can't put into words. I just say, hey, just kind of feel this out and do this. I think that comes from the 10,000 hours. I don't know if you've heard of that before.
No, this is the first time.
Yeah, it's amazing because even now people worship IQ. They don't think about no. What is the
No.
person put his passion into, right?
Hold on. Yeah, let me tell you something that everybody should know.
Okay.
Engineers are opposite of people with high IQ. And it doesn't mean that they're unintelligent. They're more intelligent than you'll ever be when it comes to engineering. The problem they have is they're dyslexic. Most of them see things backwards, which as an engineer, to put things together, it makes everything simple because you can see how they're built and put it together in your head and take a chain of 10 things and put it together. You know what I mean? Like a carburetor, you can take it apart, put it back together. And most people that are dyslexic have no problem doing it. They mechanically, they can do it all, right? With their hands, they're geniuses. But when it comes to reading, because they're dyslexic, they can't read the words correctly. So they don't get onto that. When it comes to math, they're not seeing it the way you see it. So when you teach it to them, they don't understand it correctly. So to them, you know what I mean, to the teachers and stuff, they put them in the dumb kid class because they think they just have a big learning disability. And it's not that. They just don't see the world the way you do. But give them a mechanical, object and tell them to rebuild it. You know what I mean? They'll do a perfect job every time. It's the craziest things, and you find some of the best engineers and the best things that you find. People are dyslexic.
Yeah, you're totally right. I'm horribly dyslexic. So if I read something, I don't understand it, but it stays in my mind, and then I figure it out. And being left-handed even makes it harder, makes it way harder. And I think you're dyslexic. I mean, you seem like it, where you just don't fit in the molds of the conventional because your mind's going in a whole different direction. And I can't spell. If I write a sentence, say it's 8 words, and you look at how to fix it, you know how the word will tell you how to fix it, misspellings and all of that. Every word in it has to be fixed. It's crazy.
Well, let me tell you this. I spent a lot of time in the, dumb kid classes because I read very slow.
I was in the dumb kid class too. Maybe we were together.
It was that I read really slow, but I do math really fast. I as fast as I can write it, I could do it in my head probably twice as fast. So
wow.
I don't have a problem in other areas. I just couldn't read very fast. It's because I couldn't see the words right. They jumble together. They go backwards. You know what I mean?
And they
never looks right. Yeah.
Like symbols.
But you put me in a room and you say, okay, build me this wood project. Not a problem. You tell me, build me this metal project. Give me the welder. You know what I mean? Give me a project like that. Put this carburetor back together. 325 pieces to it. Let's do it. You know what I mean? Give me something that I can put my hands on, and I'll take care of it. But don't put me over there and read your books because I'm not that guy. I need the book read to me. I will not do well with it. But everything else, just like that, man. So,
but you're so precise and scientific in your approach. I think that's the math side. I think mathematics, even if you're not doing math, you're still going to be precise in what you do. Because math, you can't sort of, the table, the what I need is about 6 or 7 inches. No, it needs to be 7 inches, and that can't be taken away from Pete Rose says, Shawn, can you repeat that, please? Yikers. I'm sorry I'm reading this a little late. Repeat. Excuse me. Shawn, can you repeat for Pete? Okay. Repeat for Pete. Shawn, I went to the same college as Plotinus and Plato. Huh. Plato's. Oh, wow. I've read some Plato. I've played with Plato too.
Talking about two different things, Shawn.
I know. Let's see. I'm trying to figure out. Sorry, he's trying to fix his chick's headphones. Okay.
You got some weird stuff going on there, Shawn.
Government schools equal indoctrination camps. Yeah, today
Yes,
especially.
yes, they do. Don't go to college out here. It's horrible.
Yeah. One estimate I know of is Tesla's magnifying transmitter extra coil was driven at 220 kilohertz. I'm writing that down.
Okay, you know what would be a fun show, Shawn?
What's that?
For you, me, and Jarvis to sit down with Tesla's patents and go over them and give our perspective on each one of them.
Oh, yeah.
Because you build a lot of Tesla coils, I build a lot of Tesla coils, and Jarvis has a very unique look on all of it when he read through it.
He knows Tesla.
Yeah, so I think that would be just a show to do on a weekend and just, you know what I mean, get it out there. I think it would be amazing.
I'm up for it. We'll have to ask Jar Jar. He's been busy. He's a good guy taking care of his family.
He says he's down with it.
Ooh, awesome. We just got to plan it, huh?
Yeah.
I'd love to do it. And just pick a patent that we can read up, take our own notes, and then jump on it and talk about it. I'm game for that.
Yeah. Maybe pick out like five patents, maybe 6, and then we'll all throughout the week be able to write our notes about it. Yeah, I agree with that.
Yeah, it sounds good. Pete Rose says, Shawn, we lose everything after HS, okay, high school, if we don't use them. They say we average a 5th grade education if we don't use it in everyday life. That's so true. When I was a drill sergeant, the learning materials, because you're getting teenagers from across the states, and usually it's not the highest IQ people are enlisted. And I learned that it was a 5th grade level. Boot camp was a 5th grade level as it related to academics, because you have to learn a ton in boot camp. Naval history, Navy this, Navy that, the language, the acronyms. So that's interesting that he's saying that, because it's very true. Interesting. Thanks for sharing, Pete Rose. So let's see here. Charas Rosen says, electric field of a dipole decreases with distance following an inverse cube law, Shawn. Cube law. Yeah, that's true. Yeah, the strength of a field it's not even linear. It's this inverse cube. It's basically, it cuts off half by half by half in your measurements. It's not this sort of, this ramp down with the field strength. The field strength is boom, just sort of steps. I'm so dyslexic. I'm trying to show you on the camera. It's I'm so blind I have to do this to read, but then I look ridiculous, and then I'm as blind as a bat. Sorry. Let's see. Michael Merrick says, Shawn, good stuff, man. Thank you. David Williams says water hammer, but it's electricity. I've never heard of water hammer.
Oh, water hammer is the best. Okay. Water hammer is a natural pulse wave. So when you take your pipes in your house for your plumbing, try turning off a valve halfway to your dishwasher or something, right? What's going to happen is the pipes will hammer. You'll hear a boom, 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 right? What it does is it creates a natural pulse wave in your house. Okay? So just think about it. You're hitting something at a high volume of speed, so then a pulse wave comes right off of it. Well, say you have something electrically going and it's resonant. Now you hit it with a pulse wave. It's like hitting it with a piezo buzzer. It'll amplify it and it'll drive it up to a higher volume. So I call it resident frequency because you call resonance frequency two frequencies, right? Put together to resonate. Well, the resident frequency is the maximum amount of energy that you can get. That's created with two frequencies and a pulse wave. So, yeah, dude, water hammers, awesome. It's put it at the bottom of the pyramid, and it hits the bottom over there with the piezo going in the quartz, in the granite. Sorry, the quartz in the granite. And, man, it makes a huge difference. If you've ever taken granite and put it in water and you want to check the conductivity of it and you put your multimeter on it, it'll show conductivity. Hit it with a pulse wave, and it amplifies right away.
What?
Yes.
Have you done this?
Yes. Just little bowls of water with granite in it.
What?
That's it. So it's so much more important than people realize. And once you understand how to do that, man, your whole world changes in understanding what you're actually doing.
It's just everything is vibrating. Everything has a frequency and ready to vibrate. It's fascinating. We have pipes that bang in our washer and dryer system, and it's a constant flow of water when it's on. But those pipes, we finally had to have it fixed because it was vibrating the whole house.
Oh, so you said it right there. Everything has a vibrational frequency.
Yeah, it's every object yet in the universe.
So think of it this way. What if it has 3 that you have to hit? What if it has 4? What if it has 5? Which amount's going to activate that object? So that's what's so fascinating to me, Shawn, because everything has a vibrational frequency. We always say like horses on a bridge, right? But how many frequencies is that? 5? I mean, think about it. There's a lot more than just one. And then that's what activates the frequency in it, right? To shake that bridge. And you go, oh man, what if I have wind going by? It's not just one sound in the wind.
No.
All the sounds that are there.
Yeah.
I mean, that's what is so curious about this is there's multiple frequencies to unlock certain things.
Yeah. Yeah, I know you're right. You're right because you can see them. If I skip in my testing of the resonant frequency of a coil 2 of the secondary coil, I'll find another resonant frequency. And I'm like, it's confusing sometimes because at first I thought, no, there's only one. What is this? And then I found another one. And I thought, okay, there's a lot more frequencies that are resonating that we just picked the first one. It's always the first one. It has the highest magnitude.
Check it out, Shawn. I'll tell you this again. When you look at the ring, you see it from the side, right? It comes like this, and then it goes till it gets to the really big one, right?
Yep.
Every single point is a point where it resonates again. So as you go like this, that one, all the way down the line till you get to the end and it discharges, right?
Right.
So think about it this way. If I wanted to create a directed energy beam, all I have to do is create multiple, frequencies like that, then cut them at a certain layer. You know what I mean? And make the strongest thing in the world because I'm multiplying the amount that goes in there at that same frequency and cutting out the rest. So anyway, that's for another topic. But
Yeah.
It was one of the answers to the propulsion things you guys are talking about and why they're making resonance propulsion now.
Yeah. It's fascinating. I want to jump into that, but my brain is down to 5%.
No, it's been 2.5 hours, Shawn. I was figuring you're going to call it like 10 minutes ago.
Yeah, no, I'm having so much fun. But I'm on a timer for my medication, so I start to wear down. But I love listening to you. I love the chat, and I'm surprised you guys hung in with me for an hour. That was awesome. And
Don't ever be surprised, Shawn. Everybody loves you here.
thank you. I was telling my wife I have nothing. She's like, just show what you videoed. So, so it's great to see you guys. Much love to you in the chat. And Nathan, I appreciate it. Do you have your end video?
Yes, I do.
Awesome.
Let me say goodbye to everybody. I want to thank everybody in the chat for showing up today and watching. I want to thank Shawn for coming on and presenting today. Guys, you've all been awesome. I really do appreciate it. Have yourself a great day.
Yes, much love, guys.
The old man builds. The old man builds. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality was stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.